to try this, correct? All right. So, I think some of these were probably pretty quick and easy, and I'm not sure if you had any trouble on any of them. Was there any that you need me to go over from MAT4? All of it? Really?
Open that much.
You did what? Well, show it to me on Monday, and I'll still give you the points. Deal? I'll do what I can for you. All right. So let's make sure earbuds are out, phones are away. Here we go. Yes. Works for me. I like that answer. Yeah. Yeah, so like number 11, if you look at it, number 11, you have 3 rows, 2 columns. So this problem is a 3 by 2, and letter A is a 2 by 2. Being that we're just subtracting them, these have to be exact if you add or subtract them. So just give me a no for it does not work or can't do, or if when you actually learn to do these on the calculator, it'll say a dimensional mismatch. So something like that. But is there anything, I mean, is everyone okay with doing the dimensions? Rows?
Yeah.
By columns? Okay. So is there anything that I can help you with on any of those? Yeah. 6? Explain why the matrices in number 3 can't be added. Wait.
No.
Explain 2 pairs of matrices can't be added. So I can't add matrix A and matrix F. Let's say you chose those 2. The reason I can't do that is because A is a 2 by 2 and F is a 3 by 3. They're the different dimensions. The dimensions have to be identical to add or subtract them. That's really what we're looking for. Okay? It's going to be a little different when we start multiplying today, but we'll get there. And that's, yeah. 2. What are the dimensions of matrix G? G is 3 rows by 1 column. Okay? Anything else? Feel comfortable with that? Good? All right. I'm going to probably mark that off here. Sophia, was there any other questions from last night that you need help on?
No.
You're good? Okay. All right. Everyone's happy? Nobody's crying? All right. Laura, are you okay? Yes, español poco. All right. So, if you needed more time dealing with those, that's fine. Hey, what was the number in front of a matrix that's not part of the matrix? What was that called? It's a coefficient. It's also called the scalar. Okay? All right. So let's take a look at notes at 5. And let's go ahead and take a look at these. So problem number 1, if I am adding 3 matrices together, watch this. Ready? Here, we're going to do this. This is going to be bad. I'm going to try this. I'm going to try this cold. It'll be on video. Draw. All right. Ready? This get combined. Okay. Hang on. I got more colors. This get combined. Okay. We got to remember we have that negative there too. This get combined. This get combined. Those get combined. And it's a different green in it. Yes. Okay. So those colors go with each other. The big thing that you have to watch out for is you have that subtraction sign. So let's see if we can just walk through it, make sure we feel comfortable with it. If I go 8 plus 0, I'm looking at only the yellows. Agree? 8 plus 0 is 8. 8 minus 6 is? It's plus 6, so 8 plus 6 is? 14. Okay? All right, let's look at the pinks. 6 minus 5. 1. 1 minus 11. Negative 10. Okay, go to the aqua color. 7 plus 8 is 15. 15 minus 10. 5. 5 plus 2. 7. 7 minus 1. 3 plus 1. 4. 4 minus 7 is 4 plus 7. So that's 11. And then the darker green, 0 added to 3. 3. 3 minus 12. Negative 9. Okay. Is that colorful enough to look at? Can you see where we kind of went through the problem?
Yeah.
Is anyone kind of stuck, a little confused? Now, yesterday I told you if you have a minus sign, just make it a plus and distribute the negative. But, friends, if you have like highlighters, like you might be this person that highlight works beautifully. Okay? But you also might get to the point where you're going to run out of color highlights. I'm lucky I have a digital thing that allows me to do a whole bunch. All right. So everyone feels comfortable with that. That's a little bit of last night's homework on steroids, though. Agree? So let's take a look at problem number 2. So the very first thing I should do is distribute. So I'm going to get 15, negative 9, 0, 12, negative 3, 3. And then watch this. I'm going to make this plus negative 4. What's half of negative 4? Negative 2. What is negative 4 times negative 2? 8. What's negative 4 times 0? What is 1/4 of negative 4? Negative 1. What is 3/4 of negative 4? I'll just do it. It's negative 3. What is 5/2 of negative 4? Anyone know? It's negative 10. So negative 4 times 5 is negative 20. Negative 20 divided by 2 is negative 10. And then what do I add together? 15 and negative 2. Give me 13. And then negative 9 added to 8. 0 added to 0. 12 added to negative 1. Negative 3 added to negative 3. 3 added to negative 10. There's our answer. Okay? So that's definitely how you would go those. Give me a fist of 5 if you feel comfortable about those past problems. 5 being a good, fist being like, dude, there's like stuff. So I think I got a 5. Maybe I might be at a 4. Got a 3. Isabella, Izzy, what can I help you with on a 3? What part? Was it this problem or was it another?
It's the second problem.
That one?
Yeah.
Okay, so let me see if I can clarify this for you real quick. Okay. You're okay with the term distribution in math? Okay. So are you okay that I went 3 times 5 to get 15 to do all that? And then the hard thing is the fraction. Does that kind of hang you up, or are you okay?
So I don't get why you think it's
Oh, okay. So basically, I'm distributing negative 4 to everything. And being the negative 4 is getting carried in there, that's going to change to a plus. Sometimes that makes it simpler. On the problem we did over here, I didn't change all of these signs. I just went 8 plus 0 minus negative 6, so plus 6. So I had already distributed. I was already carrying it through when I was talking through doing all the different colors. Okay? So there's not a right or wrong way to do it. The hard thing is if you have multiple matrices in a row and one of them or two of them being subtracted, is remembering, because these could have a big string of stuff,
The real cool thing is when I teach on the calculator, you're gonna be like the best day ever because you're gonna be probably mad at me that I make you do arithmetic. Did that bring your 3 up to closer to a 4?
Yeah.
Okay, good.
All right. So let's take a look what we have here. Oh, uh-oh, what happened? Dude, wait. All right. So to multiply, oh, look at that. We're learning stuff because we're filling in the blanks. Such a high level of learning. To multiply two matrices with dimension R by C and R sub 2 times C sub 2. In this case, C1 and R2 must be the same. Okay? Trust me on this. I'll get you through it. So an example, a 2 by 3 can be multiplied. Oh, we put the word can. We learned big. Can be multiplied by a 3 by 5 because this 3 and this 3 are the same. So the inside dimensions are the same. Okay? So a 2 by 3, oh, we're going to learn big, can't be multiplied by a 2 by 3 because this 3 and this 2, the inside dimensions, not same. And I know that's going to be like, Stirrup, what's this R sub 1 and C sub 1? Oh, vape alarm's going off. Let's go see if they'll share. The things that go on in Stirrup's Edge, you never know. So let's go through filling these out, and then I'm pretty sure I'll be able to get you to see how this is going to work. Okay? So if two matrices R sub 1 and C sub 1 times R sub 2 and C sub 2 are multiplied, the solution matrix has a dimension of R sub 1 by C sub 2. So the outside numbers tell you what the answer would be as far as the dimensions. Okay? Which means, example, if I have a 1 by 4 and a 4 by 2, the inside dimensions are the same. They can multiply. The outside dimensions will tell me what my answer would be in a result. You're like, what? Okay, trust me. All right. These can be multiplied because the inside dimensions are the same. So what is the answer going to be? The result. A 3 by? That was a higher level thought because I already prodded you on it. But yeah, this won't work. Nope. Nope is a really good math answer in the world of Stirrup. I don't know if other math teachers accept nope, but I kind of like nope. The reason that doesn't work is the inside dimensions are not the same. Now, like, Stirrup, talk to me about this inside dimension stuff. Okay. So I think we can make this little work a little bit. First thing, let me highlight this. Draw. What's that green matrix right there? Do you see that one? What do you feel the dimensions of that matrix would be? 2 by 3. I have 2 rows by 3 columns. Okay? Now let's look at our other matrix that's right there. I think you're right. So we have 1, 2, we have 3, and it's a 3 by 4. So this blue one is a 3 by 4. My friend, with what you've known so far, can the dark green and the aqua color matrices be multiplied together as they sit? Yes. And Dr. Matischuk's right there. He's going to agree with that. It's like talking to my wife. He just ignored me. All right. So yes, these can be multiplied because the inside dimensions are the same. So if the inside dimensions are the same, what would the answer dimension matrix be based on what we just talked about? 2 by 4. Okay? So the inside dimensions, same. Outside dimensions, say giddy up. You got it. Go ahead. Okay, so this is how it works. So do you agree so far that a 2x3 is the green matrices? So we're set there. And do you feel that the blue matrix is 3 rows, 4 columns? So we're good on the dimensions. I just name it. Okay? They mathematically have nothing to do with what the matrices are worth. It's just how many rows by how many columns. So if the columns of the first, okay, which is 3, matches the number of rows on the second, that is an automatic. Those are inside dimensions because they're inside what we paired them up. So I don't want to list this out of order. I don't want to say a 3x4 is the blue and a 2x3 is the green, because this is going to destroy everything you've ever known about math. Is 5 times 6 the same thing as 6 times 5 in the world of math? Right? Except for matrices. If I multiply this matrix and this matrix together, you can get a completely different answer if you were to flip the 2 exact same matrices. If you have a 3x3 and a 3x3, and you multiply here and here, the answer is going to be different than if I flip them around. It just ruins everything in math. That we said, hey, look, you didn't need that 5 times 6 and 6 times 2, are you saying? And it's, oh, that's the associative property in geometry, yay! I have part of my proof. And I start, what are you talking about? I just forward it. Okay, did I help you on that? And then, so if the insides are the same, the outsides tell you what the result matrix will be. The 2x4 is not the answer. That's not the answer of me multiplying. It's just, this is what, if I were to multiply these together, which I haven't shown you how to multiply yet, but my multiplied answer will have 2 rows and 4 columns. So it's like a combination of this one and this one. Okay? All right. Hey, friends. Number 2. What's the dimension of the matrix C on the left side on number 2? 2 by 3? 2 by 3, yes? Okay, so I have a 2 by 3. What's the dimension of the other one? 2 by 3. Friends, can I multiply a 2 by 3 and a 2 by 3 together? I can add them and I can subtract them. Agree? I can't multiply. These are different. These will not multiply. So does not exist, or nope. They won't multiply together. All right, what about number 3? What does number 3 look like? How many rows does the left one have?
1.
So 1 by what?
4.
What's the one on the other side? Say 4 by 1. Are the inside dimensions the same? So what? So these can be multiplied. What would my answer be? A 1 by 1. What are you doing? You're crazy, Stirrup. All right, 2 by 3 and 3 by 3. Inside dimensions same. Multiply, yes or no? Yes. What's the result? 2 by 3. All right, big breath. You feel comfortable with what we've just done? Anybody stuck? Anyone afraid? I'm a little bit scared. I might not sleep well tonight.
What is this?
I know. I looked at the next page. You know, make the next page much better. Do me a favor. Take your finger, stick it in your nose. You still following me? Once you pull your finger out, stick that same finger in your neighbor's mouth. It'll make you feel better. I mean, it's good enough. It's good fun. All right. Oh, my goodness. Steps to multiply 2 matrices, A times B, to give you matrix C. When you have square brackets around a letter, rather than write a whole matrix C out, we call a square bracket around a letter. That's the name of the matrix C. So I don't know what the dimensions of matrix C A is. I don't know what the dimensions of matrix C B are. And I don't know what the dimensions of matrix C C are. The only thing I would know as far as that very top line is matrix C A and matrix C B have inside dimensions that are the same, saying that we can go ahead and multiply them together. Is that okay? All right. So let's see. Let's go slow. It says determine the size of the original matrices so we can determine the size of the solution matrix. Hey, that's what we just did on the previous page. Fist to 5 if you understand what we did on this last page. Fist to 5 on that. Inside dimensions good. 4-3. Chase not voting. Yeah, let's see. 1, a thumbs up, and 1. Oh, it went thumb to a 5. I like it. All right. So that's what step 2 is. Says multiply each element of the first row of matrix A with each element in the first column of matrix B in order. Then add these values. This becomes first element of matrix C. Okay, repeat step 2 by row 1 of matrix A with each column of matrix B until each column of matrix B has been used. Okay, oh wait, number 4. Then multiply each element of the second row matrix of matrix A with each element in the first column of matrix B in order. Then add these values. This becomes the first element of the second row of matrix C. Repeat this process until a solution has been obtained. What? When are we going to ever have to use this in life is usually the next statement that comes out of students' mouths. That is a whole lot of... What? You just said you went with dimensions, give me a result, I'm kind of go okay with that, and then you just told me I'm going to take all of this times all of this and add it together and it becomes this. Man, okay. Let's see if it gets a little better. Okay. Oh my gosh. Oh my goodness. Oh my. Okay. That is an unbelievable amount of information that even having a degree in math and look at it going, why? So let's do the stirrup method. Lillian, were you always here or did you just come in? Okay. I didn't shake your hand. I knew I wasn't perfect. Okay. Holy cow. Okay. Is it safe for me to say that right there? It doesn't matter if it's in English, Spanish, Farsi, Russian, German. Now we have no idea what You feel that way? Like that scares me. Like I feel like I might, get sick to my stomach. I might make myself go throw up just for fun because that's oh my gosh, holy cow! All right, let's do the stirrup way. Is the stirrup way been okay so far? Can I do the stirrup way? Okay. Holy cow! Oh my gosh! All right. All right. I just want to look at that. I'm sorry you can't do the same zoom on your paper. Okay. Big breath. And just kind of repeat to yourself, I still trust stirrup. I'm going to go real slow. Step 1. What is the dimension of the matrix C on the left side? 2 by 3. Everyone good with this? That this is a 2 by 3. And we all understand that 2 by 3 is not 2 times 3 to give us an answer of 6. Is that okay so far?
Yes.
We're good? Okay. My friends, what is the dimension of this matrix C on the right? 3 by 2. Now, what I have just taught you today, can I multiply these two matrices together as far as what you know so far? So what is the inside dimension? The inside dimension is 3. That is the first thing. This basically says, yes, we can multiply. What will my answer matrix dimensions be? 2 by 2. It's going to take this 2. So my answer is going to result as a 2 by 2 matrix, meaning my answer is going to have 2 rows and 2 columns. Is that okay? Are you still with me so far? Okay, we're doing the stirrup way, yes? I'm going to do the best I can. This is the first row. this is the first column. Let me stop there. At this point, it would be really beneficial if you had some sort of calculator, okay? Not because I want you to solve the whole matrix, but this would be a really good idea to have a calculator. And I got a bucket of them here. You don't need anything fancy, but it'd be really beneficial if you had this because the stirrup weight might be very helpful for you to do. And all I'm worried about right now is the 246 being multiplied with the -1, -2, and -3. You with me so far? Okay? All right. Does everybody feel comfortable so far? Okay, we're going to multiply basically 6 numbers together right in this very moment. Are you with me so far? And if you grabbed one of my calculators or you have your own calculator, this is a bigger one, your calculator should be able to do this all together. But I'm going to tell you what to put, and then I'll tell you where to go plus or minus, okay? You with me so far? Okay, so now, without me doing any math yet, basically I'm taking the whole blue row times the whole blue column. Are you still with me? Make sense? All right, so I'm going to tell you the first number. That's not going to be the answer yet, but I need you to have it on your calculator. Okay, does this make sense? All right, so my friends, what is 2 times -1? -2, so make sure you have -2 on your calculator. Okay, that's not the answer yet. You're not going to hit enter yet. You still with me? All right, I'm going to go, what is 4 times -2? -8. That's the next number. So -2 plus -8. Don't hit enter yet. Still with me? Okay, then I'm going to go 6 times -3, which is -18. So we have -2, we have -8, and we have -18 that we're all going to add together. If I add that all up, what do I get? Okay, do we get it? Someone else to verify -28 is correct so far? Are we good? All right, hey, friends, give me a fist of 5 on this part. Because we're not done. Because right now, that's only a 1 by 1 for an answer. Our answer is supposed to be a 2 by 2. You still with me? Okay. Deep breath, yes? All right. I'm going to erase the blue and the blue. Because I already have my answer. You still with me? All right. Now, just to not confuse things, I'm going to change this. So I'm going to take the top row times the second column. Okay? Did I switch? Did I switch? Yeah, ready for the calculator. So, is that like an olive color? I'm going to be wrong with my colors because my cones, my eyes have been fading. It happens to males when they get older. Guys, trust me. If a girl says, "Why are you wearing that?" It's because you don't match. Even though you look in the mirror going, "Well, I match." I mean, I dressed myself this morning. Do I match? Okay.
Yeah.
Okay, good. You want to know why? Because my wife has like little things she's put in the collar of my shirts and jeans so I can match them. Okay. Now you're trying to figure out the sarcasm. Okay. All right. All right. Ready? So I'm taking the top row. Yes. Times the right column. You with me so far? So that means that's going to be the answer right here. So I'm going to take the top row times the right column. It's going to be the answer on the right side of the -28. Still with me? All right, we're going to do the same thing. What's 2 times 3? 6. Put 6 on your calculator. Don't hit enter. What is 4 times 4? 16. 16 is the next answer. So we have 6 plus 16. And then what is 6 times 5? 30. So we're going to go 6 plus 16 plus 30. How much? 525. What? 52. Oh, I shouldn't write with a highlighter. 52. Does everyone feel comfortable with that? So 2 times 3 is 6. 4 times 4 is 16. 16 and 6 is 22. 22 plus 30, 52. I like this. All right, friends. So far, we have 2 of the 4 answers. Okay, can I erase the olive green? Let's get rid of this. Oh, come on, man. There we go. All right. Friends, I want to congratulate you because you're done with the top row of the first matrix. We're moving to the bottom row. And we're going to multiply the bottom row times the first column. You guys all ready with your calculator? Okay. So I have 1 times negative 1. Negative 1. Put that on a calculator. Don't hit enter. We have 3 times negative 2. Negative 6. Put that on the calculator. Don't hit enter yet. And then we have 5 times negative 3. Negative 15. So I think we're adding up negative 1, adding to negative 6, adding to negative 15. And what do we get? Negative who? Negative 3, 2. 22 or 32? 2, 2? Do we agree with that? I mean, I put the wrong thing and you guys yelled at me. It made me feel bad. I'm just kidding. All right. We only have one more math operation to do because our answer is supposed to be a 2 by 2, and this is a 2 by almost 2. Agree? So I'm going to erase this, and I'm going to erase this. They're gone. I think I'm going to erase it. Trying. There we go. One last time. I'm going to take this times this. Okay. Whew! 1 times 3. 3. Okay? Put that on a calculator. 3 times 4. 12. Put that on a calculator. 5 times 5. So what is 3 plus 12 plus 25? 40. Is this a 2 by 2 matrix? My friends, we just multiplied 2 matrices together. Isn't it good that I have 77 or more of these to do for us? Okay. Friends, this is exactly how you do it. So I just want to put this, see if we can do this. Ready? This is a 1 by 3. What's the other one? 3 by 2. Are the inside dimensions the same?
Yeah.
So that means I can multiply. What is my answer going to be? A 1 by 2. Okay, I think we can do this. Ready? 1 by 2. It doesn't have to be that big. 1 by 2. I bet you we can do this. Ready? This is all we're doing. This times this. See what your answer is. And this times this. I'm going to see if I can get the answer in my head. Okay, I actually did 3, and I got plus 4 minus 3. So that's 2. Okay. Whew, that's my answer. Down below is the work. I had to do the math. Sorry, I couldn't do it in my head. Did you get this answer? So here's where you have to be okay with writing stuff down. Okay, so your answer for this one is literally negative 2, 2. That is your 1 row, 2 column matrix. Okay. All right. Let's see. Use the following matrices to do these operations. What time are we out of here? Hey, friends, I'm going to say this. Let's say that we work on try and get 1 through 6 by Monday. Try it. Just try it. Give me an honest try, and we're going to get you there, okay? Have a good weekend.
Thank you so much.
Are we good?
Yes.
Cool.